Topic 1, History of Earth, Lesson 2, Geologic Timescale, found on pages 164 to 170 in your textbook. We're going to start with our Connect It on page 164. So we need to circle the unconformity. What does it tell you about the history of this location? What can you infer about the history based on these rocks, and how could you use the information in these rocks to organize events in Earth's history? So a gap in time, figure 1. This unconformity represents a gap in geologic time of about 65 million years. The remaining rocks tell the story of how Earth evolved over geologic time. So we're going to circle the unconformity, which is here. When you look closely, it's kind of hard to tell in this picture, but I feel like it's a lot easier in your workbook. But it's where the rock looks different. So it's not the same like texture. It's a different section. And if you would like to see it in my book as opposed to your book, if you're still a little unsure, just come up to me and ask me, and I will open my textbook so you can make sure that you're getting that correctly and know what you're looking at. So now answering our questions, what can you infer about the history based on these rocks? So forces inside Earth folded the rock layers, then erosion occurred for a long time. Later, newer rock layers got deposited on top of the much older ones. How could you use the information in these rocks to organize events in Earth's history? So I could organize the events into those that happened before and after the erosion. So the geologic time scale. When you speak of the past, what names do you use for different spans of time? This is ultimately the geologic time scale. So it is the record of the geologic events and the evolution of life forms as shown in the rock and fossil records. A timeline of the 4.6 billion years of Earth's history. Reading check. How do scientists organize Earth's history, and what evidence do they use? The geologic timescale records events over Earth's history. Scientists developed it by studying rock layers and fossils. Dividing geologic time. Divisions of the geologic timescale depend on events in the history of life on Earth based on the fossil record. The Precambrian time covers about 88% of Earth's history, from 4.6 billion years ago to 541 million years ago. Few fossils survive from this time period. Eras. Eras are long units of time. There's the Paleozoic era, It's where life increased in complexity and Pangea formed. The Mesozoic era is dominance of dinosaurs and Pangea breaking apart. The Cenozoic era is when mammals evolved to become the dominant land animals and the continents moved to their present-day positions. Periods. So eras are subdivided into units of geologic time called periods, similar to how a year can be divided into months. Each period is defined by certain events. For example, at the end of the Cretaceous period, I always say that one wrong. At the end of the Cretaceous period, major volcanic eruptions coincided with the impact on Earth of a huge asteroid. All right, so reading check. Provide one example of a defining event for a geologic time division. So the Mesozoic era is defined by the dominance of the dinosaurs. Microscopic fossil evidence, figure 3. This image produced by a scanning electron microscope shows the microscopic shell of fossil foraminifera. Information recorded in the shells of these ancient single-celled ocean organisms provides evidence with which scientists track past changes in Earth's climate and refine the geologic time scale. All right, so now we're going to do our question it on pages 169. So modeling geologic time. Suppose your friend makes his own model of the geologic time scale. He decided to use a scale of 1 meter equals 1 million years. Would your friend's model work? How would your friend's model differ from the geologic time scale shown in figure 2? Answer, it would be much longer. It would be difficult to look at my friend's model because of its size. 2, what would be one advantage and one disadvantage of your friend's model? Advantage, it could show smaller divisions of time with greater details. Disadvantage, it would take lots of space to show all of Earth's history. So again, just pointing this out, if you did 1 meter equals 1 million years, there's 4.6 billion years, which means there would be 4,600 meters in your friend's geologic timescale, which is, I would say, probably a little bit more than we could actually do. All right, so now we're going to turn back to page 166 and 167 to fill out the geologic timescale. So the geologic timescale is based on physical evidence from rock and fossil records that show how Earth has evolved over geologic time. The divisions of the geologic timescale are used to organize events in Earth's history. So first, after you read the rest of the lesson, calculate and fill in the duration of each period. So we are going to do that now. So your numbers should show accordingly to how long each period was. Remember that the duration is in millions of years at the bottom. Next, we need to use the time scale to identify the period in which each of the organisms pictured below lived. So the Velociraptor was during the Cretaceous period, the Woexia was during the Cambrian period, and the Smilodon was during the Quaternary period. Finally, we need to draw lines from each fossil or rock pictured on the right to the part of the timescale that represents when it formed. So first we have our cyanobacteria that date to about 3.5 billion years ago, and because of that, we know that it belongs in the Precambrian time. Next, we have limestone and shale containing fossil coral from Kentucky and Indiana, which provides evidence that a shallow sea covered much of North America during the Silurian period. So our line needs to be drawn from the limestone shale to the Silurian period. And finally, geologic evidence such as these deposits from an ancient glacial lake in Washington suggests that a period of major global cooling, began about 2.6 billion years ago. So 2.6 billion years ago, or 2.6 million years ago, not billions, that makes a huge difference. 2.6 million years ago is the Quaternary period. All right, and that brings us to our lesson 2 check. So let's answer these questions. Number 1, what is the geologic timescale? The geologic timescale is a record of the geologic events in the evolution of life, and it forms as shown in the rock and fossil records. Now we need to use figure 2, which we just completed in the lesson, to help you answer questions 2 and 3. So how is Precambrian time different from the other divisions of the geologic timescale? So the Precambrian is the oldest block of time, and it lasted much longer than the other divisions of time. We also know that this time period did not provide a lot of fossils and such, so there isn't as much evidence, which could allow us to jump to the conclusion that that is why there are not smaller periods like there are in the other eras of time. So because there wasn't as much evidence left of that time period, we couldn't break it down into smaller parts. Next, how is the geologic timescale divided? The geologic timescale is divided into eras and periods, which are defined by major events or changes that occurred in the past. 4, explain why you think the geologic timescale will or will not change over the next 20 years. So the geologic timescale will likely change because it is based on evidence from the rock and fossil records, and new evidence is always being discovered. Scientists will also date rocks and fossils more precisely with advances in dating technology. 5, give an example of physical evidence used to organize Earth's history on the geologic timescale. So fossil microorganisms found in sedimentary layers could be used to identify when a change in climate occurred, or to refine a period boundary on the time scale. And that finishes our lesson 2 check, which allows us to come to a close for lesson 2.